All right, graphing secant and cosecant. What I've done first on page 9 is sketched out our unit circle and wrote the coordinates on each quadrantal. We're going to use this to create our table. What I want to do first, though, is show y'all what secant and cosecant actually look like on the graph. Let's start with secant. Whoa! So here's what secant looks like, and then I'll show you the difference with cosecant. So very similar, just a different phase shift. So similar to sine and cosine, how they look similar, just a different phase shift. So to create our table, I'm going to go to each of these angles and write the coordinate. We are looking for secant. Secant is the reciprocal of cosine. So I'm going to look at the x values on my coordinates, but I need to do the reciprocal, so flip the fraction. So at 0, the x value is 1. If I do the reciprocal, it's still 1. Go to pi over 2, the x value is 0. The reciprocal of 0 is 1 over 0, so that'll be undefined. At pi, the reciprocal of -1 is still -1. Reciprocal of 0 is undefined. Reciprocal of 1 is 1. So now I'm going to go over here and I'm going to plot these points. So at 0, 1, at pi over 2, we're going to be undefined, so I'm going to have an asymptote there. At pi -1, 3 pi over 2, I'll have an asymptote, and at 2 pi, it'll be up 1. So if you notice, this looks like the cosine function, and that's how we're going to be graphing secant. We're going to graph cosine, except every point that's on the sinusoidal is going to be our asymptote. So I'm going to continue across the whole graph using this pattern. I'm basically just graphing cosine, but then I'm going to plot the points a little bit differently. So all these coordinates on the sinusoidal are now going to become my asymptotes. That's what undefined is. Asymptote, asymptote, asymptote. And then like I showed you earlier, we're going to plot those little parabolas. So on these maximums, our parabolas are facing upward. And here they're going down. So now technically these are minimums and these are maximums. Whoa. And that's secant. Oh my gosh. Okay, let's do the same thing for cosecant. So this time we're getting our sine points and doing the reciprocal. So I'm looking at all these y values. So the y value at 0 is 0. So that'll be undefined. Pi over 2 is 1. Pi is undefined. 3 pi over 2 is -1. 2 pi is undefined. And again, that's from looking at these y coordinates and doing the reciprocal. So if I'm going to plot these points, I'm basically just graphing sine. So here's my sinusoidal. I'm going to graph the parent sine function. So we know starts at 0, ends at pi over 2, and the middle's at pi, and then goes up and down to create that S shape. I'm going to repeat this pattern across the whole graph. And then just like we did for secant, everywhere it hits the sinusoidal is actually our undefineds, our asymptotes. Asymptote, asymptote, asymptote. Oh, no, no, no. Not there. Asymptote, 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 asymptote. And now draw the actual lines, those little parabolas. Pew. Oh, hello. Pew. 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 There's so many people that talk to me. Okay, yay! And there's cosecant. That's it. So basically, if you know how to graph sine and cosine, you can graph secant and cosecant. You're just plotting it a little bit differently. The other thing that's going to be different when we turn the page and do some of the key features is the equation of the asymptotes. So let's remind ourselves how to do that on this cosecant parent graph. So if I asymptote E. So that's when you do x equals, and you just pick an asymptote. So any of our asymptotes would work. I'm going to choose 0. Plus or minus to show there's more asymptotes to the left and to the right. And then we use the K for our constant. And now for sine and cosine, or I'm lying. Have we done tangent and cotangent? Have I done this? Have I do this? I'm getting confused between this and my own level. Oh my gosh, we haven't even learned this. Okay, wow. Let's rewind. Let me teach you the equation of the asymptote. So if we're going to write the equation of our asymptote, it'll be x equals, because they're vertical lines. And now I'm going to pick an asymptote. So I pick 0. Plus or minus, because there's more to the right and more to the left. K represents any number. Well, I guess whole number. So any integer. We get it. Because we could be adding once to the right, or twice to the right, or 3 times to the right. Once to the left, twice to the left, 3 times to the left. So K. And then how far apart are they? They are pi apart. Have I taught you this? I guess not. Maybe that was on level. Oh my gosh, fun. So there's the equation of our asymptote. Okay, turn the page. We'll do 4 of these problems together. I have a couple more pages after this for you to practice on, and then you have homework in Schoology. Okay, so number 1, the first thing I like to note is whether this is the reciprocal of sine or cosine. This is cosecant, so that's the reciprocal of sine. So if we are going to do sine, the first thing I'm going to plot, or I guess let's answer some questions. Period, there's no b value, so it stays 2 pi. Vertical shift, we went down 1. Phase shift, there's nothing in parentheses, so no phase shift, and we'll save all these guys for after. So I'm going to plot my sine function with these transformations. So I went down 1, so my sinusoidal is down 1. Sine starts on the amplitude, or sorry, starts on the sinusoidal and ends on the sinusoidal. So I'm going to end on 2 pi. And in the middle, we're on the sinusoidal. And then we go up and down the amplitude. The amplitude is 2. So I'm going to go up 2 and down 2. And now I'm going to repeat this pattern across the whole graph. All right, now for the plotting. Everywhere we hit the sinusoidal is our asymptote. And now I'll plot those parabolas. Okay, there's our graph. Let's go back and list our key features here. Okay, so equation of the asymptote. X equals, pick an asymptote. There's one at 0, plus or minus k, and it's pi apart. If you notice, this value after k is always going to be half the period. Okay, domain. My domain is not all real numbers anymore because of the asymptotes. So the way I'm going to write it, I'll go down here, is it would be all real numbers, except x does not equal any of the asymptotes. Well, I already said where the asymptotes were here, so I'm just going to copy that for my domain, but say my domain does not exist here. Cool. For range, we skip a section. So I go all the way down to negative infinity, and then I stop at -3. We touch -3, so I'll use a hard bracket. Then I pick back up at 1 and go all the way up to infinity. Domain's down there. And there you go. Okay, let's do another one. Number 2. This one's a fun one. Still cosecant, so we're still graphing sine. The period, 2 pi over 2, simplifies to pi. We're going down 3 to the right, pi over 3, and we'll do this after. So if I'm going to graph sine, we'll start down the sinusoidal, down 3. Sine is sinusoidal and ends on the sinusoidal. Well, it ends at pi. In the middle, we hit the sinusoidal, and then we go up and down the amplitude. My amplitude here is just 1. So in the middle, I'm going to go up and down 1. Okay, so this graph is going to be super small. So I'm going to copy this pattern. I'm just going to go a few times. I'm not going to go across the whole graph because I'm lazy. Okay. Everywhere we hit the sinusoidal is an asymptote. Oh my goodness. That's a little baby graph. Little baby. Okay. And now for our parabolas. Cute. And then essentially that would be across the whole graph. We get it. Asymptotes. X equals. There's one at 0. I love that. Plus or minus k. And then how far apart are they? Half the period, pi over 2. Domain, all real numbers except where that asymptote is. And then for the range, negative infinity. And then we skip from -4 to -2. And then all the way up to infinity. Cutie! Okay, that was cosecant. Now we have a couple secants. Secant is cosine. The period is 2 pi. Vertical shift, nothing there. Phase shift, oh my gosh. I didn't go to the left pi over 3. Oh no. Pretend there's no phase shift. Yay! Pi over 3 would be 2 of the little lines. Each line is a 6th. Oh my gosh, crying. Great. We're going to the left pi over 6. I'm going to do it this time, I swear. Okay, and we'll save everything for later. All right, cosine. And again, this is a negative cosine. Oh my gosh, I better not forget that. So I'm starting on 0 because there was no vertical shift. Cosine starts on the amplitude. This time I'm going to do a minimum because it was negative. And I'm going to start at negative pi over 6. That's one little line here. I'm going to start down the amplitude, so down 1. And I'm going to end down 1. The period is 2 pi, but we shifted to the left, remember? So same thing there. And then in the middle, go up the amplitude. Okay, now I need my points on the sinusoidal. So between the max and the min, between the max and the min, repeating this pattern across the whole graph. And everything is just over 1/6. Pi over 6. Where I hit the sinusoidal, that's who gets the asymptote. And then my parabolas. All right, asymptote x equals. This is 2 lines, so that's a third, 2/6. Plus or minus k, pi apart, half the period. Domain, we'll copy that, but say that's where it's not existing. And then my range hopped from -1 to 1. Love that. And there's a secant. Let's do another secant. So again, we're still doing cosine. The period now is 2 pi over 1/2, 4 pi. Ooh, big one. Plus 2, so up 2. There's no phase shift. We'll do everything later. Don't forget our amplitude has switched to 2. Vertical shift, we're shifting on up to here. I'm graphing cosine. So I'm going to start up the amplitude. So up 2. There was no phase shift, so I'm allowed to start on 0 this time. And I have to end on 4 pi. 4 pi is somewhere off the graph, so I'm not going to graph that. But I know the middle of 0 and 4 pi is 2 pi. So at 2 pi, I'm going to go down the amplitude. And then between those, we hit the sinusoidal. So let's copy that pattern across the whole graph. Yay! On the sinusoidals, we got our asymptotes. And then graph the parabolas. Ooh-wee, this one was fun. You agree? All right, asymptote. I see one at pi. X equals pi plus or minus k. Well, how far apart are they? Half the period, 2 pi. Domain, all real numbers, except x isn't where the asymptotes are. My range skips over 0 and 4. Cutie! All right, you have several to practice on. I'll see you for your quiz on Friday. Bye-bye.